Welcome back to Intrinsic Intelligence YouTube channel. Today we are going to discuss on a system design concept, consistency models. So consistency models can be applied to any distributed systems and we will look into what is consistency models, what are all the different types of consistency models and which consistency models we have to choose when we consider availability or when we consider consistency. So we'll move forward. So what is consistency? Consistency model is an abstraction. So it will we call it as an abstraction, or else we call to evaluate the correctness of the distributed system as well. So where and all the consistency models can be applied. It could be on the databases or it could be on a distributed system which is spanned across multiple networks, geological geolocations, etc. So there are different types of consistency models. Majorly these two are the at a high level we need to concentrate. One is stronger consistency and another is weaker consistency model. So before going into what is stronger consistency model and the weaker consistency model, we'll look into what is consistency stands for in asset properties. Asset property is a database uh, property or a principle which A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. In ACID, consistency means if a table or a column has some unique constraints, suppose say it is a primary key, or or the value should not be negative, or the value should not be zero, or the value should always be a positive number greater than or equal to a zero. So these constraints, after we write into the database, so these constraints on a column or a table does not change. So consistency in an ACID ensures that. And what is consistency in a CAP theorem? CAP theorem is usually applied to a distributed system where C stands for consistency, A stands for availability, and P stands for network partitioning. So logically, consistency in a CAP theorem for a distributed system, it guarantees, suppose if it is scalable and it is across the networks, so all the data or the retrieval, or if you are retrieving any value at any network nodes, it will be always same across the nodes. So this ensures consistency in a distributed system. Coming back, so what is eventual consistency? Eventual consistency is a weak consistency model. So weaker in the sense there is no ordering. If we are sending requests to the service, there is no strict rules or conditions to have ordering of execution of these requests. These requests can happen at any ordering. So in this way, this ensures high availability of the network. So for example, we in a day-to-day, while we are hitting an internet, so domain name system which converts, suppose we are typing www.google.com, it converts into the domain name into the IP address which the request has to it. So the domain name system is a very good example for this eventual consistency. It does millions of hits and it finds the lookup for millions of uh, domain names and return back the values necessarily. And it basically follows the eventual consistency model. And another example is a Cassandra. Cassandra is a eventual consistency, applies a eventual consistency model. In that way, it ensures high availability. So Cassandra is one such. If you want to go to a NoSQL database and you always want to ensure the NoSQL database is highly available. So and it also supports network partitioning or scalable. So we can go for Cassandra. Next is casual consistency. So casual consistency, how it works. So basically casual consistency categorizes the request into dependent and independent operations. So whatever are the dependent operations, it ensures the ordering, and whichever is independent operations, it does not ensure ordering. So casual consistency model examples could be commenting on any social media platform. Suppose if there is a post and if thousands of members are commenting, and there should be an ordering, because people will on the comment one, people will do a reply and comment back. So there should be a chain of comments we should show, and there should be also If someone is commenting on comment 1 and comment 2, the ordering depends, it could be depends on a timestamp or anything. So casual consistency model ensures certain operations as dependent and certain operations as independent, and also ensures only the dependent operations are following the order. Next is sequential consistency. Sequential consistency is stronger than casual consistency. So it preserves the order which is requested by the client. So the client's program ensures or requests few ordering. Depends on the client program, it ensures SQL consistency ensures the order. So in which the requests come in, it ensures depending upon the client's program request, it ensures uh, the same order. According to maybe it follows the timestamp as well. This is quite an important strict consistency or linearizability. So this always ensures the strict ordering and no matter what. And a classic example we could say is Google's Spanner database. That database ensures most of like almost most of the operations are followed to be a stricter consistency model. Stricter consistency model ensures a read request from any replicas will always get a latest write value. The only disadvantage of this stricter consistency is the performance issues. So if we follow a stricter consistency, obviously the performance will take a hit. So we should consider those while designing any system design if you are taking into a high level for consideration while we going for stricter consistency model. So the stricter consistency model also suppose if we take one classic example, we are logging into a system with username password and we are changing the password. So if we change the password, so we log in with the older password. So the older password should not be referred. So the older password should be replaced by the newer password. So these systems should follow the stricter consistency model. Banking transactions and any payment related transactions should it will always follow a stricter consistency model. This is all about the consistency models which we are planning to discuss today. If there are any more questions or examples you find for stronger consistency or a weaker consistency models, please do comment that in the comment section. And thank you once again all. Thank you for watching this video, and for more such videos, please do follow Intrinsic Intelligence and subscribe for regular updates. And I have also provided the GitHub repo link. Thank you once again and have a very good day.